All right, you guys, today we're going to talk about heat and temperature. And I have to apologize for my voice. I have a little bit of a cold, so sounding a little raspy today. Most of the time, people think of heat and temperature as kind of the same thing, but really they're not the same thing. So we're going to talk about what they are and what makes them different. Temperature. We're going to start off with temperature. Temperature is really a measure of how much motion our little particles have, our atoms and our compounds and our molecules. How much motion? How fast are they moving? How much are they moving? And you guys have this diagram in your notes, and you're going to want to draw this stuff down and fill in the boxes that are empty. But we have over here on the left some hot water, 90 degrees Celsius, so almost boiling. And those particles in there, those water particles, are moving really fast because they have a high temperature. Over here, these water particles are 10 degrees Celsius, so almost freezing. And because the temperature is much lower, we're going to have much less motion. These particles will be moving slower and won't be moving around as far either. Okay, if you need to pause the video to draw your diagram and fill in the boxes, go ahead and do that. So how do we measure temperature? Well, we use these things, and you've seen them a million times. They're called thermometers. And these ones, we have a lot in Minnesota, right? It's supposed to be today on January 3rd, like -10 today. It's awesome. A lot of these you'll see in class with Celsius and Fahrenheit on there. If you're sick, you might get one of these at the doctor, and a lot of times little kids get thermometers put right in their ear to get their temperature. But how do these thermometers work? Well, regardless of what kind you're using, you have some sort of liquid substance, most of the time this red liquid, that is trapped in this little glass tube. And what happens to things as you heat them up? What happens to the water in a pot if you heat it up and you don't watch it? Your pot can boil over, right? Well, that's because when you heat that water up, that water expands, it gets bigger. So what happens is when you, let's say you put the end of this red liquid into some warm substance, it's going to start heating up that red liquid. Well, that red liquid will expand as well, which will then make it move up on the thermometer. One slight problem with measuring temperature, is that it's kind of arbitrary. So we had some scientists with the last name Celsius come along, and he said, well, yeah, if something is this warm, it's going to be 22. Room temperature is about 22 degrees Celsius. I'll name it after myself, Celsius. And then some other scientists came around, and he said, no, 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 no. My scale says that it's 78 in here, in Fahrenheit. Well, really, it's the same temperature. You're just using two different, very arbitrary scales. And you could even take that one step further, and you could use Kelvin, which is a completely different scale that measures temperature and heat. So the problem with temperature is that, depending on what scale, you get completely different values. And then the value loses some of its meaning because it's so arbitrary. Okay? Heat is a little bit different. Heat is the flow of energy between two objects. Okay? It's only considered heat if it's transferring from one object to another object. And heat always moves, always moves from the hot object to the cold object. So from the object that has more heat to the object that has less heat. So in our example from earlier, and you can draw this in your notebook if you'd like, we had our hot water and our cold water here. Hot water on the left, cold water on the right. Well, what's going to happen is if this barrier is small enough, that heat, there's more heat on the left, is going to transfer from the hot to the cold. So it's going to transfer heat over to the cold water, and it's going to continue to do that until both water samples are the same temperature. Once they reach the same temperature, heat transfer will go equally in both directions. There's a couple different ways that heat can transfer, and that's radiation, conduction, and convection. Here are some examples of different ways that heat transfers. Radiation is when something is giving off heat. So if you take your hand and you put it about a half an inch away from your partner sitting next to you, you can actually feel the heat that's coming off of their body. That's heat that's being radiated. Even though you're not actually touching them, you can still feel that heat. This would be similar to, warming up your hands by a fire without actually touching the fire. Or, if you have a hot stove, you get your hand close, you can feel the heat coming off the stove, but you don't actually touch it. If you actually are touching an object, that's conduction. So you put your hand on a hot stove, and that energy, that heat energy, is going to transfer from the hot stove, which is hot, into your hand, which is cooler. Um, Convection is the third kind, and that has to do with moving liquids or air, that's hot and cold moving together. And hot will usually rise and cold will fall. Now that concludes the notes that you're taking for today. So you should have this first page all completed. Your task now is to look at the second page, this table, and you're going to follow these directions.